Hello, Namaskar, Adab, Sat Shri Akal, Kem Cho. Welcome to Gyanatri Rupraj and I am Rupraj Day. So welcoming all to my channel. And here, before starting the video, how you people are? Good? Yeah, lockdown is there, but then also be at home, stay safe, stay healthy, and do something innovation. We know that we people are having a complete change in our life because of this lockdown and because of this pandemic. Then also we are not stopping with doing something new, right? And because of that only you people are here also, my dear students. So today, before starting the chapter, the topic, I would like to discuss that what changes you observed here before the lockdown and during this lockdown. Many changes you can observe, many changes you have seen, right? Yeah, and here in this session we will discuss few changes in context of the topic. Yeah, so you have already studied physical change and chemical change in your lower classes, right? Right? Yes. So in today's session, first we will see by showing you example, and you have to find out which one is physical or which one is chemical change. So let's start the video.
So everyone, you can see there is in down it's coming www.menti.com. So you have to go visit there, and then you have to type the code. The code is 961140. 961140. That code you have to give, and then you have to submit the answer. Now what is the question? The question is based on the example which you have seen. From there you have to tell that which one is an example of a chemical change. So two options are here: making a dough or formation of curd. So making a dough or formation of curd, which one is the correct answer? You just think correctly, go to menti.com, enter the code 961140 and submit your answer. So let's see who will give the answer reply correctly. Yeah, start. Okay, one answer came. Any more answer from your side? So first answer, formation of curd, that is fermentation of curd. So curd may form from the milk after fermentation. And there is another thing, making a dough. So using a flour, making a dough. So which one is chemical change? Anyone? Okay. So anyone else going to give the answer? Okay, someone is giving answer as a making a dough. Okay, let it be this much. We will see what is this. First, what is this? Which one is chemical change and which one is making a dough? You can also find out which is this. So we will go there. Let's see what is with chemical change. So we have seen the examples and examples of the changes. One was the example of physical change, another was the example of chemical change. There you have seen, I have given you the question where fermentation or formation of curd, right, takes place, and making a dough. If you say the dough is prepared from flour, right, so it can change the shapes, but in formation of the curd it's happened because of the fermentation, and as because of the fermentation it happens, this becomes, from milk it becomes curd. So this curd is acidic in nature, and it is taste bitter. It is milk is not taste bitter, right? That's why as the fermentation occur, because of that the curd completely get changed in a chemical composition based on the compared to the milk. That's why that is the correct answer. Yes, formation of curd is the chemical change, is an example of chemical change. So wherever we find any chemical change, all this type of chemical change there, chemical reaction is occurring. Yes, chemical reaction is occurring there. So chemical reactions we can find many places in many areas we can see in our daily life, right? For an instant, if we take an example of crackers, if we take the example of crackers, the crackers are having many metals, right? When different crackers uses many metals, right? One such metal is magnesium. When this magnesium is burned, right, so when it burns it produces a dazzling light flame, right, white flame, and then after burning it is converting into a white powder. So this is also a chemical change. Now if we see burning of magnesium is taking place with a dazzling white flame, and that is converting and changing into white powder, this is a complete a big sentence where we are mentioning about a chemical reaction, right? This chemical reaction is happening, but always is it possible to write an chemical reaction in a such a manner, in a such a long way? Is there any way to write it in a shorter form? So we will see how we can write it in a shorter form. The writing in a shorter form we called it as chemical equations. Yes, chemical equation we call. Chemical equation we can depict in a word also. If we are writing it in a word, for an example, if same taking the example of magnesium, magnesium is burning. So magnesium is taken, the magnesium ribbon, and then is burned. When it burns in presence of oxygen. Yes, it burns in presence of oxygen. Air is contain oxygen, so without oxygen no burning process takes place, so oxygen is required. With this what will happen? The white powder is formed. Yes, the white powder is magnesium oxide. Magnesium oxide. So this is what we depict them, represented it in a word form. But what about making it more simpler, more shorter way to write it? Yes, we can do that also, and that is what we have to write it in a formula. Yeah, we have to write it in a formula. So we know that every elements, every compound is having their own formula. We mentioned that elements in a formula basis, right? So writing in formula, if we see magnesium Mg, oxygen, it remains as in molecule form O2, and it gives magnesium oxide MgO, right? So this is what we can write it in a formula. But if you see this side, this is what left hand side, and this side is the right hand side. This left hand side, this magnesium is 1, and in right hand side magnesium is 1. It's okay, it's equal. But two atoms of oxygen in this side, but here only one atom of oxygen. Now is this balance? No, it is not balanced, right? We can see okay, one side is 2 oxygen, another side is only 1 oxygen, so it is not balanced. So how to balance this equation? And here we will see how we can balance the equation. So let's start. We will see how we can balance the equation. So what we have seen, balance the equation, right? So we have seen magnesium is there, which is getting react with the oxygen, and it is giving magnesium oxide, right? So this side, left hand side, is are the reactants, right? These are the reactants which get react, and this magnesium oxide are the product. So it is the product, right? So this one is the product. So what is happening? The reactant is reacting and it is producing the product. So if we have to balance it, we take this thing in a stepwise manner. First step is to make two category, LHS and RHS, and we have to check out whether it is equal or not. So magnesium and oxygen is present only. Magnesium and oxygen which is present, magnesium is present here only 1. Here oxygen is 2, left hand side. Right hand side magnesium is only 1. Oxygen is only 1. Right. Now the second task is we have to find out which one is more, right? So, and before going which one is more, we have what we have to do. We have to make a box. So to make it a very simpler one, for an example like this, I am making it a box. Now making a box is because when we make a box, we don't have to disturb this box, right? Everything whatever as it is, these things are there in the equation. Before balancing, we just have to make the box, so we don't have to disturb that area, right? We don't have to do anything there. Now if you see which one is more, oxygen is more, right? And here oxygen is very less, so we have to first balance the oxygen. Now if I will write 2 here, so it will be 2, so it becomes balanced. But 2 into 1 is 2, but magnesium also became 2, so this one is also became 2, right? 2 into 1 2, so magnesium 1 only is there, so 1 is not written, so that we have to assume it 1 because it is 1 only. So 2 into 1 1, right? So 2 and 2 into 1 2, right? So 2 and 2, but again the condition happens, this magnesium is not balanced. So as this magnesium is not balanced, what we will do, we will make this also balanced. Now is everything is balanced? Yes, everything is balanced. So at last, after completion, see this is a heat and trial method. This balancing is a heat and trial method where you have to strike out, you have to consider which one is more, then you have to balance the other side with that, then you have to try the another one. Like this is heat one. If you have corrected it, that's it. If you are not correct with the balancing, then again you just consider the another one. So this is heat and trial. After balancing, completely balancing it, you just have to consider whether everything, you have to just recheck it whether everything has been balanced or not. So 2 magnesium, 2 magnesium, 2 oxygen, 2 oxygen, right? So this is balanced here. At the end, the last step is writing physical state, right? Physical states. So this compounds, this chemicals are remain in a some physical state. What are they? Solid, which we denote it as S, liquid, which we denote it as L, then gas, which is denote is as G, and then aqueous, which we denote it as AQ. Now what is aqueous? Aqueous is a some solution in the water, right? Solution in water. So this solution, the chemical present in a solution in the water, that is what we denote it them as aqueous, right? So this is how we can depict this equations. Clear? So I hope you are clear with the balancing. So how we can do the balancing? So sometimes we don't have need to do balancing also. Sometimes we need to do balancing. That we have to check, right? When we will check it out, then we will find out, we will understand what we have to balance it, right? So now moving to the topic, right? So here we have balanced the this one, so it will be 2 here and it will be 2 here. So you have to understand how we can do the balancing. Now the next thing we will see the different types of chemical reactions. Yeah, different types of chemical reaction. The first, which here according to your textbook we have to study around, we have to see around 5 different types of reactions. The first one which we are going to consider is combination reaction. What is combination? Something get combined. In this reaction also, 2 or more products, reactants are getting combined together to forming a single product. For instance, for an example, if you are looking at this CaO, right? This is called quicklime, right? This is called quicklime. Quicklime, right? This is called quicklime. This quicklime, when it is get mixed, chuna, you know chuna patthar jo hota hai, for brushing it into the wall use karte, तो quicklime को भिगोते हैं. Now what happened? This forms calcium hydroxide. This is calcium oxide, but common name is quicklime. Then water, and then calcium hydroxide. This calcium hydroxide is known as slack lime. Yeah, it is known as slacked lime. This is slack lime, right? So like this is another example where this carbon is an example of coal, right? In coal also carbon are present. So this, when coal burns in presence of oxygen, so whenever something burns, it burns in presence of oxygen only. So in presence of oxygen, when it burns, it produces a gas, that is carbon dioxide gas, and this is what an example of burning of coal, right? This is an example of burning of coal. This is an example of respiration where glucose is getting breakdown in presence of oxygen. I have said that 2 or more reactants, right? So 2 or more reactants, when it is combining, so it is forming single, but here it is double product. But then also here we are considering it a combination reaction, as because it is producing energy. This production of energy is also same here also. This is also required heat, right? Heat, it is also producing heat. This one is also producing heat. कोयला को जलाते गरम करने के लिए ना, खाना वाना बनाने के लिए, कुछ करने के लिए, so heat निकलता है. right? Heat is releasing. Slack line जब बनता है तो heat is releasing. That's why, and this is an example of, that's why this process, that respiration process also has been included in the combination. And as in all this combination reaction, what is happening, the heat is releasing, that's why energy is releasing, that's why it is an exothermic reaction. It is an exothermic reaction, right? So combination reaction are generally exothermic reaction. Next, which we will see is decomposition reaction. Yeah, decomposition reaction is where a single reactant, yes, single reactant get breaks down into simpler products. Yeah, it breaks down into a simpler products. Now how it break down, it break down with some things, that things, based on that things which break down the single reactant, we have classified this in three category. The decomposition process is classified in three category. If you see, this is one, first is thermal decomposition. Thermal decomposition is what? Thermal decomposition means where the heat is required, thermal heat. So with the help of heat, when it is getting breakdown, that is thermal decomposition. Electrolytic, electricity is required. Photo, sunlight is required. So this three things required for the decomposition, for the breakdown of a single reactant. That's why this is in categorized in three different category. And everything you can see, what is required, energy is required something to break down. That's why this decomposition reaction is known as a endothermic reaction. Endothermic reaction, yeah, right? So we will see one by one. The thermal decomposition, thermal, as I have said, it is the heating, right? So here what is happening, heating is happening, right? So heating is happening. So heating, due to heating only, the thermal decomposition process. So this is calcium carbonate. This calcium carbonate is what it is, we called limestone. So this is limestone, it breaks in presence of heat. This breaks in presence of heat and it forming quicklime, remember quicklime, yeah, and then it release carbon dioxide. So this is what thermal decomposition, right? So heat is required in this process. So what is this? Limestone. Limestone, right? This is limestone, calcium carbonate, right? Next we will see the electrolytic decomposition. What is happening in electrolytic decomposition? Electricity is required. Electricity is required. So in presence of electricity, here the breaking down of a single product is taking place. So I'll just show you the example how this is required. Now if you see how electricity is required, if we take a beaker and here two rods are capped, right? And this rod is connected with electric supply, and this is positive end, this one is negative end, right? And this is filled with water. This is filled with water. Now what, when the electric supply is passing here, this water which contain hydrogen and oxygen, this will get breakdown into ionic form. So H plus ion and then O2 negative ion, right? When this will break down into two different categories, right? After breaking down, this H plus ion and O2 negative ion will be formed here. Now this, what will happen, the positive ion will attract towards the negative rod, right, which is connected with the negative, so it will go here. And this oxygen which is connected with the positive and it is negative charge ion, so it will move here. Like this, oxygen and hydrogen get separate out, and this is what we call electrolysis. So what is happening here, the H2 is getting breakdown and form H2 plus O2, right? Like this, the formation of hydrogen and oxygen takes place. due to the electrolysis process. So this is what we can find: H2O, which is breaking down in presence of electricity and forming H2 plus O2. Right? This is what we call electrolysis. Lysis means breakdown in presence of that is electricity, and breaking down of what? Water. Could you find this thing balance? Could you find this thing balance? Yes or no? Yeah, we can't find this thing is balanced way, as because here hydrogen is 2, hydrogen is 2 also, here same equal, but oxygen is 1, here oxygen is 2. So how we can make it balance? Yeah, so if we make oxygen is 2 here, so if we write 2, so oxygen become balanced 2, but again hydrogen is become 2 into 2, 4. So here it is only 2. So what we have to do? Here we can write 2 more. So 2 to the 4. Now it is balanced. Right? Understand? This is what we have to do, balancing. We have to keep it in mind about this balancing. Next, we are moving into the third decomposition, that is photo decomposition process. Photo decomposition process, there sunlight is required. Right? What is required? Sunlight is required. In an instant, for an example, if we take uh, silver chloride, it when it is kept in the sunlight, what happens? This turns gray in color. Right? This turns gray in color. Now, why this is happening? As because the silver chloride in presence of sunlight breaks into silver and chlorine. Yeah, silver and chlorine, and because of that it becomes green color. Now, could you find any difference in this? Is this balanced? Is this balanced? No, again chlorine is 2, chlorine is 1, so we have to make it 2 here. So chlorine balanced, but again silver is 2, became 2 here, but it is 1 only. So now silver is also balanced. Another example we take. Now we are using this type of digital cameras now in this generation, in this time. But earlier there was a very still camera, no digital. It was not digital. It was used with the reel में आता था, right? उसको खींचते थे negative. It is forming the negative. In that type of photography, black and white photography, एक चीज यूज किया जाता था, that is which we called silver bromide. Silver bromide is used in that type of black and white photography. There also what happened, when we click this, the silver bromide get exposed in the light, and because of the exposure in the light, वो silver and bromine जो है अलग अलग हो जाता था, जिसके कारण से एक shape आता था, negative आता था, and from that negative photo used to be developed, right? So this silver bromide again, which get breaks in silver and bromine, again it is not balanced. Yes, is it? Yeah, it is not balanced. So what we have to do? Bromine is 2, so here we have to make it 2, and then this silver also we have to make it 2, so it is now balanced. So we have seen the 3 types of decomposition. Could you tell me what are these 3 types of decomposition? Yeah, first one is, which we have seen, correct, thermal decomposition. The second one, electrolytic decomposition. Exactly. The third one, photo decomposition. Very good. So these are the 3 types of decomposition. Moving on to the third types of chemical reaction. Are you ready? Let's move. Chalo. Displacement reaction. Displacement क्या है? Now showing you this iron. I'm just taking the एग्जाम्पल हियर, आयरन है और ये कॉपर का सॉल्ट सॉल्यूशन है. दिस इज सॉल्यूशन ऑफ सॉल्ट सॉल्यूशन ऑफ कॉपर, सल्फेट सॉल्ट सॉल्यूशन बनाता है. सो कॉपर का सॉल्ट सॉल्यूशन है. व्हाट विल हैपन, दिस आयरन इज मोर रिएक्टिव देन दिस कॉपर. सो व्हाट विल हैपन, दिस आयरन विल रिप्लेस दिस कॉपर एंड टेक द पोजीशन ऑफ द कॉपर. डिस्प्लेस हो जाएगा, जिसके कारण से क्या होगा, आयरन सल्फेट विल बी फॉर्म एंड कॉपर विल मूव आउट. Now this is what we call displacement reaction. In displacement reaction, the more reactive metal get displaced out and the lesser displace the lesser one, and then it will come into the solution. ठीक है, वो solution में आ जाता है. So every cases we can't find. जो less reactive है can't able to displace, but more reactive will displace. Now you may ask, sir, how we will find out, how we will understand which one is more reactive? So my dear, we will see this one. Don't worry, we will see this one. We are going to see in chapter 3. It will come in chapter 3. Reactivity series में ये मिलेगा. So don't take the tension. We will see that one. You can see here another example, lead, which is reacting with the copper chloride and replacing the copper and taking the place here. Lead chloride and copper is getting separated out. This is what displacement reaction. ठीक है? Displacement reaction जैसा होता है, what is happening, one reactive element is removing or displacing the another one. और एक है the fourth one, double displacement reaction. क्या होता है कि double displacement में exchange of this ions takes place, right? One is saying, if you are taking my place, right, I will take your place, right? Mutual understanding होता है कि you come to my place, I will go to your place, right? You can see here this sodium sulfate solution is there, that right solution, that's why it is aqueous. Then barium chloride solution is there. What is happening here? Sodium is saying, I am coming to take the place of yours and combining with the chlorine. Then barium is saying, okay, if you are taking my place, I will take your place and I will combine with the sulfate. And hence what is happening? Barium sulfate is forming and sodium chloride is forming. Clear? So barium sulfate and sodium chloride is forming. So what is happening? Exchanging of this reactants. So ions get exchanged. So sodium is ion, sulfate is also ion, barium is also ion, chlorine is also in ionic form. So separated in ionic form and then they exchange their places. Right? So like this, double displacement takes place. Double displacement here, both are mutually get exchanged. One thing you can see here, what is happening, this aqueous and aqueous, when it is reacting, the solution is reacting, here aqueous solution is forming, right? Sodium chloride forming the aqueous solution, but this barium sulfate is forming a solid thing. Now what happened, when we take this solution, right, this solution when we take, so in solution when the reaction happens, after this reaction a solid forms and do not get insoluble thing called forms and remain down, right? It remain down, it doesn't get mixed with the solution. And this is what we, whenever in any reaction we find these things which is insoluble solid, then we call this as precipitate, right? What is we called it as precipitate, right? And wherever the precipitate will form this type of reaction, we call it as precipitation. This type of reaction we called it as precipitation reaction, right? So wherever, it is not necessary in double displacement reaction only, wherever precipitate will form, any insoluble solid will form, right? Aqueous solution is there but solid is there, right? From this physical state we can find out. So that is what we called it as the precipitation reaction, right? Clear? Understand? Sure? Moving on to the next. Ready? Yeah. So moving on to the next one, that is oxidation and reduction reaction. What is this oxidation and reduction reaction? How does this reaction takes place? We will see. If you see, I have written one name redox. In this redox, this red is denoting the reduction, right? This from reduction, this red is denoting, and this ox is denoting oxidation. So wherever this oxidation and reduction reaction takes place, we called it as redox reaction. Clear? Now we will take an example of this redox reaction, and then only we will come to know what is this redox redox reaction. So this is first is example, we are taking zinc oxide is reacting with carbon and forming zinc and carbon monoxide. Another example we will see, manganese oxide is getting react with hydrochloric acid and forming manganese chloride, water and chlorine, right? Ready? So see, here the zinc oxide, right, is having oxygen. This zinc oxide, what will happen, this zinc oxide will give away the oxygen and it will come single, right? It will give away the oxygen, वो oxygen छोड़ देगा and अकेला हो जाएगा. This oxygen is getting, when it is getting released, it was having the oxygen and it has donated the oxygen. So that is what we call as process called reduction. Yes, reduction. यहाँ पे वो ऑक्सीजन को दे दिया है, राइट? ऑक्सीजन जो है वो छोड़ दिया है. Now who has taken the oxygen? ऑक्सीजन, कार्बन जो है ऑक्सीजन को ले लिया है और लेके कार्बन मोनोऑक्साइड बन गया है. So it has taken the oxygen and that's why this process we called as oxidation. So carbon is oxidized into carbon monoxide and zinc oxide is reduced into zinc, right? So this is what reduction and oxidation. So we can say कि oxidation is a process of gaining of oxygen, right? Gaining of oxygen हम कह सकते हैं, and reduction is a process of losing of oxygen. Oxygen lose हो रहा है, right? So what is happened here, oxygen is loose, that's why it is reduction, and here oxygen has been taken up, that's why it is an oxidation. So gaining of oxygen and losing of oxygen. But what is happening here, you can see, taking this example, this hydrochloric acid is getting reduced, not reduced actually, it is getting released chlorine, forming chlorine and releasing the hydrogen, right? Hydrogen यहाँ से निकल जा रहा है. Because of this, as because from here hydrogen is getting removed out, we calling this process as oxidation. Why I am coming to that also. Hydrogen is getting removed out, it is, that's why we call this oxidation. Here the manganese having oxygen and it is releasing the oxygen and forming manganese chloride, that's why it is called reduction, right? So what is happening in this, another twist came, removing or losing of hydrogen is also known as oxidation. So we can say oxidation is process where gaining of oxygen and losing of hydrogen is taking place, and that is what we called oxidation. And same here, it will be opposite, it is gaining of hydrogen, losing of oxygen or gaining of hydrogen is known as reduction process. So this is what oxidation and reduction process, right? So likewise oxidation and reduction process takes place. I hope you are clear with this. Yeah, okay. So this is what we have seen, oxidation. So many oxidation and reduction process takes place in our daily life situation. So this is what we have seen, oxidation and reduction process here. And in daily life situation we find oxidation process and their effects also. Yeah, so for an example, chips खायो, खाते हो, you people, you eat chips. So potato chips you people eat. So it is not like that you don't eat, you eat. Now this potato chips wrapper, when you open it, it filled with gas, air, kholte, right? Now this potato chips, why this having this gas? Iron nail, kill le lo, kill, right? If you keep it outside for few days, the color will get changed. These all are the example of effects of oxidation in our everyday life we see. Yeah, so we are taking the example is one is corrosion, another one is rancidity. One is corrosion and one is rancidity. Yes, we find this thing in our daily life. Corrosion generally happens because of the moisture or acids which attacks on the metals, right? So we find the examples like iron is becoming reddish brown in color, right? We find silver which becomes black coating, काला काला आ जाता है. कॉपर जो होता है उसमें ग्रीन कोटिंग इट कम्स as green coating due to the oxidation process which we call corrosion, right? So this corrosion damage the metals actually. So we will see how we can prevent this corrosion, metals from the corrosion, but not here. We will see this thing. This topic will come again, but it will be in chapter 3. Yeah, so wait and watch till this chapter 3 will come. Till that, we will see up to this much on corrosion. Another example of this effects is rancidity. Rancidity, we cook food, right? And when we cook food, this contains oils, fats. उसी के जरिए fry करो, cooking करो, it contains fats, oils. So when this fat oil, what will happen? Oxidize. The taste, when you keep it for a few days, the taste and smell will get changed, right? The smell and the taste will get changed. Why? Because it is getting oxidized. इसलिए कोई भी पैकेट फूड, the long packet food for kept for long time, the packet food which is kept for the long time, there antioxidant is used, right? Antioxidant use किया जाता है. For an example, पैकेट के पीछे में लिखा रहता है, you can see in the back of the wrapper, antioxidant this much, this thing is used, right? So antioxidant prevent the oxidation. And in home, what we do, we keep the food in airtight container. In airtight container, we keep the food, right? So that is also another way to prevent from the oxidation. And in potato chips, what I have said, this is nitrogen gas. So nitrogen gas is present in the chips packet, which is preventing the chips from getting oxidized. So this is what few examples of oxidation process which we see in our daily life. And this is how we can prevent it from the corrosion. We will see in details, don't worry about that. So this is what with the chapter we have completed it. Yuppie, enjoy, learn, and thank you for watching. So if you have any queries, anything you have to ask, you can surely ask me. So thank you for be with me, right? Yeah, so any queries, anything. I think some one question I got about Zahidul. Zahidul, he asked me one question that displacement reaction is always balanced or what? Displacement reaction is always balanced or what? So displacement reaction not necessary is always balanced. It will always remain balanced because if we take consider an example of a salt, if you see the reactivity series wherever the metal which will have more reactivity, it will get displaced, right? So I'm just taking example of magnesium chloride, and it is I am reacting it with the potassium. So potassium is more reactive, right? Here if I am considering, it will form KCl plus it will form Mg, right? So here Cl2, so if I will write 2 here, balanced, potassium become 2. Now here I have to do the balancing, right? I have to do the balancing. So it is not always necessary ki I have balancing is not required. Balancing is required. It is depend on the reaction, what are the compounds are there. So based on that, we have to see, we have to check, cross check, and we have to find out the balancing, right? So any doubt, anything you have to ask, anything you are required to know, you are open to ask me. do comment, you can mail me, you can use the Google Classroom to ask me any queries, you can WhatsApp me, right? Always happy to solve your queries, solve your doubts and questions. So do study, do read, do go through it nicely once again, and more calculations, more practice is required. It is not a one go work. The more practice will make you more perfect. So with this, I'm taking a leave. Till then, be safe, be stay home, and namaskar. Bye bye.